connection and talking out to that, pulling an input stream back, as you can see right here, reading all that stuff, closing it. Then we see that we're opening a local file and initializing that, and then writing things out to that local file, and so on and so forth. And so even just looking at this DEX code for a bad guy, this is a tremendous amount of information that they can see about the application. And you can also, like I said, you can compile it or decompile it back to Java, and that's the process for that. Is you can basically move it back to a jar file, and then you can take that jar file, stuff it in your favorite Java decompiler, and pull that stuff back. And like I said, that's less of a deterministic process, but looking at those two things in conjunction with one another, it's pretty easy to go in and target what you want to see, and go in and like you can roughly target stuff by grepping through the DEX code, and then look in more detail. Like once you know the files and stuff that you're looking at, you can go in and look at the actual Java source code itself. And so, like I said, this is something the Java decompilation works most of the time, most of the time, and when it doesn't, you can go in and look at the actual instructions. And so one of the things that we started doing and looking at these apps is figuring out, like I said, the app itself is interesting. What it's doing on the device is interesting, but what's potentially more interesting from an attacker standpoint is looking at the stuff that these things talk out to. And so what you can do is you can go through and look for all the string constants that are embedded in the Java code and try to pull information out of that. And so we've got some regexes that we run through to show, like, well, show me all the URLs that this thing is trying to talk to. Show me any string in here that looks like a URL. Show me any string that looks like a host name. Show me any string that looks like some sort of a web path. And based on that information, I can go and run DNS against those. I can ping stuff. I can make web requests and see the stuff that comes back. And also from the DDEX assembly, it's easy to grep through and look for different method calls, and and to pull those things out so you can find out when different operations are occurring. And the same thing, it's pretty easy, like to step through and look at the data flow. And so you can watch when you're pulling information from these third-party services. Is it getting stored in files? Is it getting sent to another service? Kind of so on and so forth. And so, like the bad news for developers is that is the bad guys, you have to assume, have all your code, and potentially they may understand your code better than you. And so kind of the typical problem that you've got with smart client applications, you've got the same thing with these with these smartphone apps. So if we've got a question of, like, is there sensitive, what sort of data is actually being stored on the device, you can basically just run through and grep for file. And that lets us go in and target so that we can find out that we're writing stuff out to a file in config, and that we're reading stuff in from that file in the home screen. Now, the same thing with the Java source code. You can pull that up in your favorite decompiler. And so if we look here, this has done a really good job in this case of pulling back all this stuff. Some stuff is lost, just because it's not a perfectly it's not a process that goes perfectly forward and back. But again, like if you've got information like this, that lets you know a whole lot about what the application's doing. And so we can also go through here and find out, like in this case, when we're opening file output, that's an Android specific API for opening file stuff. We're opening a file called secret file, and we're opening it with permissions of 1, which is a world readable file. And so you're creating a file. In this case, we're creating a file that, like, other applications are going to be able to go in and see. Like normally for Android applications, each application gets its own user. on the Linux systems, it's the Android phone, and so all the files are set up specifically for that user. But with this call, by setting the permissions there, you make a file that other applications could potentially go in and look at. And so, from an audit, from an assessment standpoint, that's something that's certainly interesting to know. Why are you creating a file on this device that other applications are going to be able to go in and look at? And we see that right here where. Next, the question is what's on the server side, and like I said, it's if I want to access data, or if I know that sensitive data is being stored on the device, and I want to get access to that data, right? I can get like a sock and a potato, put the potato in the sock, sneak up behind a guy with an Android phone, and like whack him in the head, take a smartphone, and run away. There's probably other ways to do it that would work as well. But if I want, so I've got one account number, and that's great. All right, well, now I want to go and get someone else's account number. I've got to get, you can probably reuse the potato in the sock, but again, you've got to actually get physical access to the device. And so certainly from PCI standpoint, you don't want to be storing credit card numbers out. You want to be sensitive to that. Folks follow the news where they saw that the city had a problem very recent, like maybe a month or two ago, where their application was storing stuff out to the device, and then it would also get like synced to the synced back to your computer, right? and so that was a case where they'd gone to a third-party developer to develop this application. They said, well, don't put any of this stuff on the device, and the developer, I'm sure, said, aye, boss, I won't put any of this stuff on the device. And as it turns out, they're putting it on the device, and they're putting it on the device in such a way that it got, that when you synced your machine with the with the device, it would pull that stuff on there. And so so certainly having stuff on the device is bad from a PR standpoint, and again from an audit standpoint. But the really the scarier thing that we see with these applications is the question of what are they talking to on the server side. If I'm a bad guy, I would it's one thing to try and get access to devices or buy them on eBay or whatever. It's another thing to say, well, I know now about this web services endpoint that's out here, and so let's go and attack that, right? So that's something that I can do. It's not a I don't have to have access to the physical device. I'm not doing things one at a time. I'm attacking the web service where all the data is stored, and so and it's something that I can do across the network, probably across jurisdictions and whatnot. And so with the with stuff on the server side, that's the concern: is what is the what server-side resources have been exposed that you're talking to, and an example of that is when the iPad 3G came out, the situation that AT&T had, where there was like a web service that so that you didn't have to retype your email address. There was a web service floating out there. It would pass in your device ICC ID. And then the web service would pass back your email address. And so, if folks remember that, it was that was a couple months ago where it was a big hullabaloo. Hundreds of thousands of email addresses leaked, because of the iPad device. Well, that was because to build this feature, which is how many times do you change your email address? Why is that something that I need? Is is everybody that lazy that that they can't type their phone or their email address into the iPhone device once? I don't know, but so that's a situation where the problem was not necessarily the device, but the device relied on a feature that needed this server-side stuff in order to function, and that's something we also see in a lot of cases, these web services to support these smartphone applications. Just like the smartphone apps are not going through necessarily normal channels, your normal SDL, your normal review cycle. A lot of times this these web services are being provisioned and put out in the cloud somewhere, and without the knowledge of central IT or security that is normally responsible for controlling something like this. And again, the danger there is that you've got these web services that are exposing sensitive data, putting your brand at risk and all that stuff. Another good example of that, we were talking to a security company, and they've got an app that lets you go in and work with your alarm system, right? To turn your alarm system on and off via your smartphone, which is a great idea. But to support that, they had to provision all these goofy web services that would let you go in and turn your alarm system on and off. And it's okay, well, from a security standpoint, is that something? Is that something that needs to go through this review process? Is that something that we need to be concerned about, the ability to turn on my alarm, or turn on and off the alarm? By by looking at this stuff, we can find, well, what third-party web services are we talking to, or are we relying on? In this case, we're talking to, I think it's Yahoo Stocks to pull things back, and what enterprise web services are on there for, for folks to look at. And I'll run through an example here. This is a little bit of a trumped-up example, but the really scary thing is that when Dennis Cruz was doing his O2 tour, he came and hung out in San Antonio for a while, and I got him together with a buddy of mine that writes a bunch of iPhone and iPad apps, and and he said, hey, I've never really thought about the security of these apps. I've been building iPhone apps since the App Store came out. Let's take a look at the security of this. And as we chewed through his iPad application, we found the server endpoints that it was talking to, and after a little bit of fuzz testing against the services, we found a comparable problem to what we're looking at, where this like anything running this service is actually susceptible to this problem. So it's not particular to this iPhone app or this particular iPad application. It's anything that's used in this web services protocol. So we need to write that up and submit it to the guys, but. So if we go through and parse out of the DEX code all the different things that look like URLs, this is all the stuff that gets exposed. And so this lets us go and say, okay, what kind of goofy things are we talking to? We're talking to this web endpoint, this web endpoint, this web endpoint. And what we also do is look through even the things that don't look like URLs. We'll find like chunks of SQL, SQL snippets. You find things like parameter names and stuff like that. And so again, with all this information for bad guy, this gives a tremendous amount of insight into like how to prepare for an attack that you wouldn't necessarily have in a purely web environment, because the application is telling you like this is what you need to do in order to make a successful request. So this says no method provided. You send in a method parameter. And it echoes its stuff back, and then you find out that it also echoes all the like it'll echo new line characters and things like that. And so like that was something where again this it's a real basic iPad application, or it's actually a really complicated iPad application. But spending 15 minutes fiddling around with it, we were able to walk in, find out where the web services endpoints were, and then find how this web, like all the things running this web services protocol are vulnerable to this type of attack, where you can echo. Essentially it acts as a open cross-site scripting endpoint that anybody can run through. So, looking at this app, what's wrong with the example application? We're storing sensitive data on the device because we're pulling stuff back from the web service. We're storing credit card information on the device. It's trusting data from these third-party web services. It's passing that stuff through. It's exposing. It's letting attackers know what enterprise web services are out there supporting the device. And we find out that the enterprise web services are also essentially like hanging out there as open cross-site scripting endpoints, and on and on. And so, I guess one question, or like when we were looking at this, a nice thing about Android applications, at least from an attacker standpoint, is they make it, they're pretty open. They don't have to go through an app store, and they're fairly easy to tear apart. Anybody see today that Apple released some guidance on how they do their review process? And I think they specifically requested no more fart applications on the iPhone. So. It's good to have that level of transparency, I suppose, from Apple finally. So what about iPhone applications? And iPhone applications are a little bit different. They all have to be written in Objective-C. You can't write anything. Apparently now, terms of service-wise, you can't even write them in something else that gets compiled out to Objective-C looking stuff, which is an interesting decision on the part of Apple. Did they just change that? Nice. So you can now write things in whatever in Flash, and it as long as you compile them out to okay, very cool. Yeah, that That was a weirdo thing. But this gets compiled down to ARM6 machine code, which is, I'm a Java guy. I'm up here. Is there anybody here who's like a real deep, like IDA Pro type guy? Anybody? Yeah, some of that. Okay, yeah, that's at a lower level than I usually mess around with, but so this gets compiled down to that, and